Hey everyone, I'm Nick Raboy from MongoDB, and in this tutorial we're going to see how to build an AWS Lambda function using the Go programming language that communicates with MongoDB. So a serverless function built with Go that communicates with MongoDB. Now, to be successful with this particular tutorial, you will need a few things prior. You will need to have some knowledge of Go and AWS Lambda. We'll be going through it somewhat, but it will help you a lot more if you have some understanding of those two technologies. You'll also need a MongoDB Atlas cluster created. The free tier is fine in this example. Everything that we do here will work with the free tier. It will need to have a user account established or a user role. You'll need networking rules already configured, so that way your MongoDB Atlas cluster can be accessed from your AWS Lambda function. These are things that we won't necessarily explore in this particular tutorial, so just keep an eye out for things. Now, up on my screen, you'll notice I do have my MongoDB Atlas dashboard open. I am going to be using the sample data set for this example. It doesn't really matter what you choose to use. If you do wish to follow along with the sample data set that I use, so if you look at your cluster and you click on the ellipsis menu, you can say load sample data set. That will give us a sample mflix database, a bunch of collections, a bunch of documents, things that we'll be using for this particular example. Now, if I go ahead and click Browse Collections for the examples cluster that I have open, and I go down to sample mflix, in particular, I'm going to be using the movies collection. And basically what we're going to be doing is we're going to be querying this collection for documents using AWS Lambda and Go. So let's go ahead and get started when it comes to this particular tutorial. Now up on my screen, you'll notice that I have Visual Studio Code open. It doesn't really matter what you use to develop your Go application. This is just a preference of mine. I also have a few plugins installed that'll help me when it comes to importing certain packages. It's totally up to you what you want to do there. The technology is really irrelevant as long as you can develop Go applications. The first thing that I'm going to do is I'm going to initialize my Go modules so that way I can use them in this project. I'm going to say Go mod init, and I'm going to say AWS example from the command line. And that's going to create a new Go mod file. What I'm also going to do is I'm also going to create a main file. So I'm going to say touch main.go, and this is where we're going to have basically all of our Lambda code. And you can choose to do things different. It's up to you. Next up, what we want to do is we want to import both the Go driver from MongoDB as well as the Lambda package or the Lambda SDK for developing with Go. And we can do those one at a time. What we can say is we can say go get. I'm going to start with the MongoDB Go driver. I'm going to say go.mongodb.org, and I'm going to say mongo driver/mongo. And that went ahead and added the dependencies to our Go mod file. What I'm also going to do is I'm going to do the same thing for AWS. I'm going to say go get. I'm going to say github.com. I'm going to use AWS lambda-go/lambda. And if you really don't want to use the Go modules, you don't have to. This is just the package manager that I'm going to be using for Go. At the end of the day, all you really need to worry about is does your Go application compile into a binary that we can then upload to AWS. So I'm going to clear my command prompt. All right, so now we can actually get down to the development of the Go application. So we can open up this main.go file. I'm going to say package main. And I'm also going to say function main, and I'm just going to add like a comment in there for now. Because what's going to happen per the AWS Lambda documentation is basically what we're going to do is we're going to start our Lambda inside of the main function. It's going to call an actual function, usually called like handle request or something similar, which is going to actually have our application logic. Now let's go ahead and start preparing things. First of all, I know that I'm going to be working with the movies collection. And while we don't absolutely need to do any kind of mapping to our document from our Go application, it does make things a lot easier. And if you don't want to do the mapping, which we're going to do right now, you can always resort to the documentation to see how to work with BSON documents and BSON maps in their kind of raw form. But since we're going to be using an actual data structure that has annotations, that's the route that we're going to use. So what I'm going to say is I'm going to say type movie, and I'm going to say struct, and I'm going to define a few fields that exist within my document. So actually what I'm going to do is I'm going to go to my web browser, and you'll notice that this is one of my documents. We have a plot, genres, which is an array. We have runtime. We have all of these fields. Now, I'm not going to add all of them because it's just not necessary for this example, but I'm going to add a few. So back in my Visual Studio Code, what I can do is I can say, first of all, we have the ID of our document, which is fairly important for us. We're going to say primitive, and we're going to say object ID. So this is going to be of type BSON. I'm also going to add some annotations to it. So first of all, I need to know, how does this ID field in Go map to our document that exists in MongoDB? So I'm going to say BSON, and I'm going to say underscore ID. So that's the mapping. I'm also going to do a JSON mapping, because when we return our result from our AWS Lambda function, we can really return whatever we want, but JSON tends to be a more standard format. So we're going to say JSON, and in this case, the mapping is still going to be ID. So it's going to be rather similar. And I'm going to save it. And you'll notice that because I have various extensions installed, it automatically did that import for me. It's going to add a few more fields. So I'm going to say title. The title is going to be of type string. And once again, we're going to do our annotations. All right, and you'll notice that we technically don't need the annotations if we were going to use, say, for example, lowercase t or match the ID directly. But because they're not exactly the same, it's a good idea to add those annotations. So we're going to say year, and I'm going to say that this is int32. And for the annotation, I'm going to say year lowercase, and for JSON, I'm going to say year as well. So this is a perfectly acceptable data structure for our movie. And once again, we're not going to add all of the fields. You can, it's not necessary for this example, but this is more or less what it would look like. All right, so we have our data structure. Now let's go ahead and establish our connection to MongoDB. So what I can say is I can say var, I can say client or error, and I'm going to say equals mongo.connect. And I'm going to pass in a few parameters. So first of all, I'm going to pass in the context, which we can just use as background for this example. We're going to pass in our URI. So I'm going to say options.client .apply URI. And I'm going to pass in a URI string. In this case, it's just going to be empty quotation marks for now, but I'm going to save it. And the error for my options went away because our import just happened successfully. So this connection will happen outside of the main function, outside of our handler function. The reason for this is because we don't know when these functions will hibernate. We don't know how many of these functions will spin up. There's a lot of factors. We don't know when they're going to shut down. And because of that, we don't want to just add connections inside of our handler function, because there is the possibility that we spawn too many concurrent connections to MongoDB. And this isn't just an issue with MongoDB. This is a general issue when it comes to any database technology. Connections to the database are finite. So if we try to overload concurrent connections to the database, we're likely going to run into errors. So establishing this client outside of the main function or outside of the handler function means that we're going to recycle this client for as long as it might exist, or if it doesn't exist, it's just going to be recreated. So just keep that in mind when it comes to working with any database technology and a serverless function. And once again, we're going to leave this blank just for now because we're going to add our URI string when we get to that point. Now let's go ahead and add our handler function. Let's go ahead and say function handle request. And we're going to pass in a context, so we can say CTX and we can say context.context. And for now, that's good enough. This is going to be evolving over time, but we're going to get there momentarily. Now, as far as a return from this particular handle request function, what we want to do is we want to return a slice of movie because our collection, I mean, we could do a single document return, but for this example, we're just going to return several documents, and for that reason, we can do a slice of movie. Otherwise, what we can do is we can return an error. All right, so let's get down to business. The first thing that we want to do inside of this handle request function is we want to see if there was an error establishing a connection to the database. So what we can do is we can say if error not equal to nil, we can say return nil or error. So that check is out of the way. And again, that check is related to line 17 with the actual connection to our database. Next up, the next thing that we want to do is we want to get a reference to our database that we want to use as well as our collection. So what we can do is we can say collection equals client.database, and we're going to pass in sample mflix. And this is something that we can either pass it in as an environment variable, which we'll see with the URI string, or we can just hard code it. For this example, hard coding it is more than acceptable. So next we want to define a collection. So the collection that we want to use is going to be movies. And just like that, it's done. It's going to throw a little error right here because we're not using it yet, but we can go ahead and use the collection. Now, if that collection didn't exist or that database didn't exist and we try to use it, it would be created for us automatically. All right, so we have the collection. Now what we can do is we can try to establish some kind of query against that collection. So let's go ahead and establish a query which will evolve as we progress. So we're going to say cursor or error equals collection.find, and we're going to pass in a context. So we're going to say context, and we're going to say .background is fine for this example. If you want to have timeouts or anything special, you can do that as well. And we're going to pass in an empty map. And we're passing in an empty map in this example because I want to return all documents in this collection. So I'm going to say bson.m for empty. And I'm going to save it. So we have our cursor. Let's go ahead and check to see if there's any kind of error thrown. So we're going to say if error not equal to nil. If there was an error, we can say return nil and return error. Now, what do we do with that cursor? So what we could do is we could iterate over that cursor. But because this example is going to be very simplistic by nature, it's probably going to make sense for us, just for the sake of the demo, to actually convert this into a slice. So just get all of our results that could possibly exist in our cursor, create a slice out of it, and return that instead. So what we're going to do is we're going to say var movies. We're going to specify this as a slice of movie, which is based on that struct that we had just created. And we're going to fill it. We're going to propagate it. So we're going to say if error equals cursor.all. We're going to say context.background. And we're going to say ampersand movies. So we're going to load all of the results of that cursor into our movies slice. Otherwise, there might have been an error. So if error is not null, we're going to say return nil error. So we're making some progress here. So potentially we have documents inside of this movie slice. I mean, there's always the chance that we have none if our collection is empty or nothing matches our filter. But in this case, we know that we're using an empty filter, and we do have documents in that collection. All right, last step. We have to return our movies. So what we can do is we can say return movies or nil, because there isn't an error up until this point. And this should work. We don't have it wired up to Lambda, but everything should be good up until now. So there's two things that we didn't take care of yet. Well, we didn't do anything inside of our main function, which is a requirement, and we didn't do anything with our URI string for our connection. So starting with the main function, what we can do, because this is the easiest one, is lambda.start, and we're going to pass in the function to start. In this case, it's going to be handle request. All right, that wasn't bad. Now what we have to do is we have to figure out our URI string. So let's go back into MongoDB Atlas. Let's go into our database tab. We're going to say connect on our cluster, and we're going to say connect your application. We're going to decide the language that we're using, which is Go, specify a version, and this is our connection string. Now, I don't plan to hard code this in my application. I can, but it's best if we use the environment variables that AWS Lambda allows us to use. So that way it's more dynamic. We can change it up as necessary. but you could hard code it if you really wanted to. I also have my user, which has a username and password that is allowed to access the sample mflix collection and database. And I'll be adding that in just a second. So let's just keep this tab open and go back into our editor. So back in the editor, we can make a modification. So instead of passing in an empty string or hard coding it, let's go ahead and pull from the Go environment variables. So we're going to say os.getEnv. And we're going to say, give our environment variable name. I'm going to call it Atlas URI. And I'm going to save it. So that's done. Now, in theory, this should work great. And that's what we're going to test. We're going to actually we're going to build it. We're going to upload it to Lambda. And we're going to give it a test. And then we're going to make some minor modifications to see what exactly we can do with this. Now, AWS Lambda is a certain computing architecture, certain operating system. I am personally on a Mac. I am using Apple Silicon, which is definitely nothing to do with what AWS Lambda is using. So we do have to use the cross compiler of Go in my circumstance. Whether or not that's going to be the same for you, I don't know. But you can always copy my commands and it should work out great. So what I'm going to do is I'm going to say env inside of my terminal. I'm going to say Go OS because I want to specify the output operating system, which is going to be Linux. I'm going to specify Go Arc for the Go architecture, and I'm going to choose AMD 64. Because remember, I'm on Apple Silicon, so I need to choose an appropriate type. And then what I'm going to do is I'm going to say Go Build, and it's going to build for that operating system and that architecture. Now you'll notice that it created an AWS example file. That is my binary file. That's going to be what we work with when it comes to AWS Lambda. All right, so there's one more thing that we need to do when it comes to our binary. We can't just upload the binary as is. We actually do have to add it to a zip file. So depending on what operating system you're on, you can just say compress. You can use the command line if you really wanted to. We just need to make sure that we have our binary file at the root of a zip file. All right, so what can we do now? Well, let's go into AWS Lambda or our AWS Management Console. I'm going to click on Lambda. In this example, I'm going to create a function. I'm going to call this one AWS example. And I'm going to choose the runtime. The runtime in this case is going to be Go. I'm going to choose the AMD 64, which is the first one. And I am going to create a function. When it's done creating, you're going to see something like this. I'm going to scroll down. And what I'm going to do is I'm going to upload my zip file. I'm going to save it. Should take just a moment to upload. All right, it's uploaded. We're not quite done yet. So first, the first thing that's up is our handler. It's not called hello. So let's go ahead and edit it so that way we change it. So the handler is actually called AWS example. So this is the binary file that is within our zip file. So this is not the zip file. Our zip file can be called whatever you want. The handler is going to be the name of our binary file. So that's AWS example. And I'm going to click save. All right, next up, what we need to do is we need to go to the configuration tab. So this is where we add our environment variables. So what I'm going to do is I'm going to say edit. I'm going to add an environment variable. The key is going to be Atlas URI, and the value is going to be what we have in MongoDB Atlas. So what I'm going to do is I'm going to paste it in, and just make sure that you've changed your username and password to reflect whatever you're using for your application, whatever has permission, and I'm going to say save. All right, perfect. Now what I can do is I can go to test, and let's go ahead and test out this function. Now, I have a lot of documents in this particular database. Now, before I test it, let's go ahead and take a look at that because it's something I want to call out. So if I go to Browse Collections and I go to mflix and I go to Movies, I have quite a few. I have 23,000 documents. It's not going to be very fast because I'm returning everything at this point in time, but we're going to modify that in a second. But I'm going to go back into AWS Lambda. I'm going to create an event. I'm going to call it my event or whatever you want to call it. It doesn't matter what we use because we're not accepting any data yet, but I am going to test. So it looks like we might be suffering from a mixed data type issue, which is fine. Year in theory should be an integer in our case. It looks like in this case, it may also be string. It might be some other data type as well. We're gonna get around that in just a second. So let's actually, since our test, we don't actually want it to return the 23,000 documents, let's go to make some modifications to our code, and it should work out for the best. So let's go back into our Visual Studio Code, and we're gonna make some modifications. So you noticed in the test screen we were able to pass in data. So this is data that you can pass in with your function, and we're gonna make use of that. So we're gonna add another struct. We're gonna say type. This is going to be of type event type. The name isn't really important, it's just what we're choosing to use. I'm going to say struct. And in this case, because it could be anything that you want, it doesn't really matter, it's whatever makes the most sense for your application. I want to add a limit to how many documents are returned. So I'm going to call this a limit variable. This is going to be int 64. And I'm going to say JSON, and this is going to be of type of limit, so the name limit. BSON's not important because we're not actually saving this to MongoDB. We're just mapping it to JSON. So we have the event type. If we go to line 26, we can pass in the event type as a parameter. So what I'm going to say is I'm going to say input, and this is going to be event type. So now that we have input from the user, let's go ahead and modify our code slightly so that way we can determine if we want to do any kind of limits, and we probably do. So let's check it out. After our collection reference and before our find, let's add some more code here. We need to add some options, which will be passed with our find operation. So we're going to say options equals options.find. So we're going to use find options. We're going to do an if statement to see if a limit exists, because the user, we're not guaranteeing that the user has to, it's not a requirement basically to pass a limit. So we're going to say if input.limit. We could certainly make it a requirement, but we're not. If it's not equal to 0, 0 being the default here, we're going to say ops equals ops.setLimit, and the limit will be input.limit. Now, as far as what changes down below, well, we have our collection.find. We're going to pass in those options. So we're going to say ops. And that should be enough to get the job done. So if we provide a limit, which again is not absolutely required, although in this example it looks like we might have mixed data types, which we may investigate in a moment. We're going to provide a limit. I'm going to limit it to say like 3 documents. It should work out fine. Let's go ahead and go and build. So I'm going to say, first of all, I'm going to remove the old one, AWS example. I'm also going to remove the AWS example.zip. I'm going to run that command for building once again. I am going to add that file as a compressed archive here. I'm going to go back into AWS Lambda. I am going to go to the code tab. I'm going to upload once again. And we're going to test our luck on another test. So I'm going to go to the test tab, and I'm just going to call it maybe my event. Now for the JSON, what I'm going to say is I'm going to say limit, and I'm going to limit it to 3 documents here. So let's go ahead and test it out and see if it works. So it succeeded. So my theory was probably correct that we have multiple types on this particular field. But in this case, I have 3 documents that came back, only the ID, title, and year, because that is all that we included in the data structure. Now there are other ways inside of your code to, if you've got like a string data type or something else, you can always do some parsing of your data if you've chosen to have multiple data types per field, which is acceptable in MongoDB. So there's ways around this, but that's kind of out of the scope of this particular tutorial. We just wanted to see that, one, we can create an AWS Lambda function using Go. We can connect to MongoDB, and we can do some kind of query of our data. So looking back at the code just slightly, we do accomplish all of that. So we have our 2 data structures, one for user input, one for our output, which is based on our movies collection from our sample documents. We make a connection outside of our handle request and outside of our main for connecting to MongoDB. We're using an environment variable within Lambda. And within our handle function, we're just doing a basic find operation. Nothing too fancy for this example, but we're returning it in its entirety, or at least everything that was mapped to a field. And for the most part, it worked out great. So Go is probably one of my favorite ways to develop AWS Lambda functions because I can actually compile it beforehand, make sure that everything passes before sending it up to Lambda, which is a convenience that I think is a convenience. But the same kind of strategy can be used when you're using Node.js or Python or another programming language with MongoDB and with AWS Lambda. So if you like this video, please take a moment to hit that like button for me and then subscribe to the MongoDB YouTube channel. If you have a question regarding anything that I did, I also have a written version of this tutorial that you can check out, or you can drop me a comment on this YouTube video and I will try my best to answer it. Until next time, everyone, have a great rest of your day.